So I'm going to go back a little bit before I go forward. When we were organizing this in that last example and we said let's make it into a table and then we could put it into a bar graph or pie chart, and then we organized it here into the frequency table and relative frequency table, and then we stopped before making a bar or pie chart for this data, which we could definitely do. I just wanted to mention that in your book, they actually have you make a bar graph of these two, and they do this to make one solid point, and that is distortion of information. So here in this one, they start at 0 and count up to 10 and make the bar graph. This is correct. So this one is the accurate portrayal of the data. Over here in this one, they did not start at 0. They started at 3 and created a bar graph. And a lot of people would say, yeah, but that's the right numerical information. But what this is a distorted image of the data because it exaggerates the differences in the quantities. Whereas if we start at 0, we're able to see the relative, like how they are relative to each other clearly. And here it exaggerates the differences. Okay, so your book does this because they want to highlight the idea that if you don't start at 0, you are distorting the information. Okay, so just wanted to give a quick little shout out again to your book for making those kind of for making those points. Okay, now we are going to look at this and think about this quantitative or this numerical data. So consider the data about the news distribution on the internet. Okay, was a sample taken or was the entire population included in this data set? Well, certainly they included the Chicago Trib, so we're like, well, we're covered. But I highly doubt that this is all of the newspaper websites that exist in the United States. So I'm thinking this is definitely a sample. Okay, so I'm going to write that down. Was a sample taken or was the entire population included? Well, here, the population is all news websites. Oopsie, websites. And so immediately I think a sample was taken because there's no way this is an exhaustive list of all news websites. There are more than, okay, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What is that? Then 25. I think that there are more than 25 news websites. So I absolutely think that this is a sample. Is this qualitative or quantitative data? Well, it's quantitative because the question they asked was, okay, how many unique visitors went to your website? And that is a numerical answer. So this is quantitative data. Numerical, I guess, measure. To research question. Okay, fill in this table using the data. Okay, now, groups have been made of, let's see, thousands of unique visitors to these websites, from 5 to 14.9 thousands of visitors. Okay, so we need to count up how many fall between 5 and below 15, then from 5 to just below 25, then from 25 to just below 35, etc. in terms of thousands. So let's see how many fall between 5 and 14.9 or just under 15. So I see, let's start this count. Okay, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that was what, 15 out of 25? 15 out of 25. Okay. How many fall between 15 and just below 25? Okay. Nope. That's above 25, so nope. Let's see. Above 25. There we go. 1, 2, 3, 3. 3 out of 25. Okay. Next, from 25 to just under 35. Okay, I'm on it. So, looks like, nope. Yes. 1, 2, 3, 3. So again, 3 out of 25 fall between 25 and just under 35. Between 35 to just under 45. Let's see what we have. Nope. 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 None. I got none here. 0 out of 25. 0%. And then from 45 to about 55. Okay. Let's see. One, 2, 3, 4. 4 of them. So 4 out of 25 fall into the class of numbers from 45 to 55, thousands of unique visitors to their website. Okay. So we filled in our table. We created a table by bundling up numerical values. And then we counted up who lives in that class or in that range of numbers. So this class is really just, we're classifying these into ranges of numbers. But I want you to notice that they are all equal in size. So from 5 to 15, 15 to 25, they're grouped in tens. Yeah? 5 to 15, 15 to 25, 25 to 35, etc. So these are broken into ranges that are all equal in size, in their range at least. Why do we use a histogram instead of a bar graph in this situation? Oh, because these are our categories, and these can be ranked from small to large. So these are actually ordered. Okay, so probably going to need that. I just put it on the floor. Our categories can be ordered from small to large. That's why we are using a histogram instead of a bar graph. Create the histogram, label everything, and give it a title. Okay. So here we go. So it's very similar to a bar graph. except now we have numerical values along our horizontal axis. So let's go back to here. Our frequency goes up to 15 at the highest. So we could probably count by 5s or 2s and make this a nice, let's count by 2s. But we have to make it go all the way up to 15. So this over here would be number of websites. And along our horizontal is the visitors in thousands. So thousands. Thousands of visitors. And let's see, we need this to go up to 55, and we need this to go up to 15. So if we count by 2s, okay, let's see, 2, 4, 6, 8, 10, 12, 14, 16. Okay, so at the bottom here is 0, 2, 4, 6, 8, 10, 12, 14, 16. Done. Number of websites, frequency. And along the bottom, this needs to go up to 55. I'm going to count by 5s, I think. So let's see if I go 5, 10, 15, 20, 25, 30, 35. That's too big. Okay. So let's make my ticky marks a little bit smaller. How about 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 55 was the highest. 55, yes, it sure was. Thousands of visitors, I'm sorry. Okay. So let's create this. I don't know how to overlap. I can't. So the first one from 5 to about 15 was 15. Okay, so I'm going to mark this down from 5 to 15 was a frequency of 15. I'm going to need to do some horizontal bars here, or lines. Ooh, boy, that's not linear. Okay, sorry. So here's our 2. Two. 4, 6, 8, 10, 12, 13. Okay, almost done. Just to have a reference. Okay. There we go. Always helps to have a reference here. Right, our first category, 5 to 15, had a frequency of 15. So that bar starts at the 5, goes up to 14.9 or 15, and the height of it is 15. Okay, there's our first bar. And then, going purple style. And then from 15 to 25, we had 3. So from 15 to 25, there were just 3 of those. So 2 and yep. So from 15 to 25, there were 3 websites with that number. So 3 websites with 15 to 25,000 visitors. And then from 25,000 to 35,000, there were 3 websites with that many visitors. Again. Okay, so here we are at 3 again. Got it. There's our bar for that. Between 25,000 and 35,000 website visitors. Okay, at those 3 websites. 0 for the next range, or for the next category, there were 0. There were 0 websites that had between, oopsie, why did I write 35? That's a 45 for sure. Between 35 and 45,000 web visitors. And then, surprisingly, there were 4 websites that had between 45,000 and 55,000 visitors. So, 4. This is 55. Okay. So notice that we have created a histogram, which is very similar to a bar graph, but we were able to order this from small to large, and they kind of snug up next to each other because 15 is the breaking point between, so 5 to 14.9, and then 15, they're just really right next to each other because we are able to order them. So, got it. And then I did want to include a title here, visitors to online websites. Just to give a, if somebody looked at this graph, then they would know. These horizontal lines are, can be erased at this point, but it doesn't hurt. It doesn't hurt the reader to have them. Write down 3 observations or inferences you make from this data. Well, honestly, the first thing that I can see is that definitely there are a lot of visitors getting their news from websites. That's the first thing that I notice is that. So I'm going to write that down. Really? I swear I'm college educated. Their news. Okay, so first, just very vague. Lots of people get their news from websites. Okay, second, there are many websites that seems maybe local. So the majority of websites have between 5 to 15,000 of visitors. So the majority of websites have between 5,000 to 15,000 followers, visitors, whatever you want to say. Readers. But then it seems to me that there are some very popular websites. So there are, so my next one, there are a few, 4 very popular websites. And I'm guessing that you could probably guess what they are in the United States here. So, but nonetheless, well, you can actually look at the data chart and see what those are. Huh. Nonetheless, I was just looking to see if they included some other national ones, but so we took this really was a sample. And so when we talk about inferences, this is all of these are speaking to all of the websites, because this list of websites is not all of them. It's not every website with news on it. So these are generalizations that come from just this sample that was taken. Okay. Some research display their data as stem and leaf plots. Let's create one here for this data set. Okay. So here's what's up. There's 0, 1, 2, 3, 4, 5. And if we look back at the data, okay, there are some in the data range from 0 to 10, some in the range from 10 to 20, some in the range from 20 to 30, some in the range from 30 to 40, etc. So these are actually just the tens of thousands. So the stem here is really representing tens of thousands of visitors. I'm going to write that down. Tens of thousands of visitors to the website. And I think they even say unique. And then the leaves represent each one in the sample. So we're going to do that quick. I'm actually going to, I know I do this every time, I'm going to draw in some horizontal lines again, just to make sure I can keep these a little bit organized here. Oopsie. All right. Okay, there we go. So back to the data. I'm actually going to start with this one, so that you can see what it means to be in the zero stem, 0 thousands. Let's go with the ones that are between, that have at least 10,000. Okay. So here's one with 12,000, Chicago Trib. Here's one with 14,400. So when it comes to this 12,000, I'm going to represent this as, so this is 10,000 plus 2,000. So I'm going to put a leaf of 2.0. Uh-oh. Oh boy, I shouldn't have done that. Because really we need to find the smallest. So let's go with the ones that are between 10,000 and 20,000. I'm going to go ahead and circle those in. I am going to circle those in pencil really quick. So I said the Trib lives there. So does this one. That one has 10,000. That one has 10,000. 12. Okay, let's see. This one, 19, 16.8. Okay, so I've gone ahead and circled all of the ones that have at least 10,000 visitors, but between 10,000 and 20,000 visitors. And then I'm going to order these from small to large. So this 12,000 visitors would really be represented by 10,000 plus 2,000. But I notice that there's a smaller one right here. So this is 10,600. Okay, so for the smallest leaf, I'm actually going to write 0.6. And then, so I've got 0.6 or 0.6. Is this the next smallest? Is 10,000. Well, this would be 11,500. So 1.5 in addition to this 10. So I'm going to put a 1.5 to represent. Here's 10,000, and then tack on 1,500. And then, and I want you to also notice that I'm literally picking these apart. So if I take 10.6 and all I did, and I take 11.5, and I take, okay, let's put these in order, 12.0, 12.0, what would be the next one? 14.4, and then 16.8, and then 19.0, and I go like this. Whee! Yeah, what you're seeing is over here is the stem, and over here are the leaves. And if you just glue them together, you get the whole numerical value. So I'm just taking this and I'm listing them as 1 was their stem, and all of these are the leaves. Okay, so I'm going to jot these down. Okay. There was a 2.0, there was a 2.0, there was a 4.4, there was a 6.8, and there was a 9. Got it. Okay. Next category. So now this is really representing anywhere between 0 and 10,000, not including 10,000. Okay, so if I erase those, I'm done with those. Or maybe I shouldn't, and I should just avoid them. Okay, here's one, another one, yes, where they were below 10,000. Okay, all of these in rectangular boxes. Those are all of my ones that are below, anywhere between 0 and 10,000 visitors. Okay, I'm going to jot those down in red just to differentiate them. The smallest, I see 6.0 twice. So 6.0. Okay, just double checking that those are the smallest. 6.0, I see a 6.1. Okay. I see, I'm going to have to start ticking these off so that I make sure I don't double. Oh no, I see a 5.6. Okay. That's what happens. So 5.6, 6.0, 6.0, 6.1. Okay, just so that you are seeing what I see. Here was the 5.6, 6.0, 6.0, 6.1. I see a 6.3 and then a 6.5. Okay, 6.3, 6.5. Let's see, 6.3, got it. 6.3, 6.5. Okay, all of these circled ones have already been done. So I'm just going to cross them off. Like, done with you. I see a 6.6, then 2 7s. Okay. 7, 6.6, 7. And then I have a 9.8, which represents what, 9,800. Got it. And now I'm looking at investigating the ones that have 20,000 visitors, but stopping at 30,000 visitors. Okay. Oh, I had already done that one. Here's one. Here's another one. 25 grand, 22 grand, no, 28 grand, yes. Okay, got them. The lowest of which is 22.9, and then 25.2, then 25.9. Okay, new color. How about purple style? So the smallest that is above 20,000 visitors was 22.9. So we'll put a 2.9. And then we had a 25.2, so a 5.2. And then we had a 25.9 thousand visitors, so a 5.9. And we also had a 28,200, so that'll be represented with an 8.2. Okay, so going back to the data, got it, and got it. Okay, and now ones that have 30,000 visitors, nope. That is a 51.1, 54, 55, nope, nope. Okay, so there are 0 here, so we'll leave it blank. 40,000 visitors. Let's go back to our list. Ooh, I see one right here. Okay, so that one. The rest of them have 50. So this next category, let's go green, is 47,800, so 47.8 thousand. Got it. And then we're into the 50s. I don't know. We have the lowest of which is 51.1. And then there's a 54. And then there is a 54.5. Okay, so we have stems and leaves, and we have included all of the data. And our key or our legend here would say where, I don't know, let's give a random one. How about this 12? So where 2 bar 5.2 represents 25.2 thousand. Yeah. Okay, and I just picked one of these, just a random thing from the list. But here's where the bar, this is our legend of what these all represent. Thousands of visitors. What do you notice about the stem and leaf plot versus the histogram? Okay, well, where did I put our histogram? My histogram. Your histogram. Oh, right there. I noticed the following. I see that this has done different ranges. So from 0 to 10,000. Up here we had from 5,000 to 15,000. So this is also putting it into ranges of numerical classes. So a similarity here is that they're both counting how many are in each range of numerical values. I also see that it's heavy on this lower end, and then that there's a few up here. So this was a reorganization of this histogram where we put them into classes. But I also noticed that if we switch it like this and we just rotate the stem and leaf chart, it will create another histogram that looks similar, but because we had different classes, it looks a little bit different. So I noticed that stem and leaf plots are a horizontal histogram, kind of. So these stem and leaf plots are sort of horizontal kind of, in a way. All right, I have some quick remarks about all of the stuff that we just did. So, what I just said out loud is that stem and leaf make their data ranges using base 10 place values. So, stem and leaf plots make their number ranges using base 10 place values. So where we really just sliced it off and said, okay, well, a 2 before it represents 2,000. And remember, thousands or 10,000s, that's all base 10. So whether it's ones, tens, hundreds, thousands, 10,000s, whatever, tenths, etc., those are all just base 10 groupings of numerical data. And then my second remark is that when we group things by number ranges, this is just one step closer to a histogram. So grouping by range of number values, It's true that our histogram broke it up a little bit differently from 5,000 to 15,000, but the stem and leaf broke it into groups of 10,000. So from 0 to 10,000, 10,000 to 20,000. Whereas this went from 5 to 15,000, 15,000 to 25,000. So when it comes to histograms, we could have even broken it into from 5 to 10,000, etc. So the histogram gives us a flexibility of our number ranges, whereas the stem and leaf, it would be trickier to do it without, like, you could change the number ranges, but it's very convenient to do it with base 10. I guess I'll put a little star next to this and say you could create stems that go maybe 5, 10, 15, 20, and then tack on something like. So I'll put a little, sometimes modified. Okay. In order to, we could have perhaps modified our stems in order to adjust to make them look like this. Okay, so it is possible, but the stem and leaf is just one step closer to creating a histogram. All right, inference. Remember, so I'm just making this bold again because we did make some inferences, and inferences use a sample's information and extend it to the whole group. Or generalize it, I guess you could say. Extend the idea. To the whole group. Or in STATSy terms, to the whole population. Okay, so a quick summary is that this section started with, here we go, all kinds of data. Just a ton of data about news and how we get news. But it all was just data. This was not quite raw data, but because we were able to immediately put it into scatterplot, so it had been organized for us. This had already been organized, so we were immediately able to put it into a bar or pie chart, bar graph or pie chart. This was raw data. The rest of this was raw data. So we first started by putting it into tables, and then we picked, should this be a bar graph, or here, these two should actually become histograms because the data is numerical measures. And so what we did here is we actually started with data, organized it in a way where we could visualize it. But different data sets call for different organization, all of which bank on creating some sort of table and then going from there. So we added to this list frequency table, relative frequency table, bar graphs, pie charts, scatter plots. We didn't quite do this because they were already organized, okay, in terms of categories. And then we added to it a histogram for this numerical data, yeah? And in the end, what I would also like to say in summary is that really this scatter chart started this chain reaction. So when this data, when people saw the scatter chart, or I'm sorry, scatter plot, and saw that the number was going down for how many people were getting newspapers, then all of a sudden they were like, you know what? But really we should look at more data. And if we look at all of this data put together, it tells a very different story. So when I see this, I'm like, wow, that's a lot of data. But when you synthesize it and really put it all together, put all of this data and organize it and then re-talk about it, right? Like, it would be really interesting to see all of this together. So, yep, paper's going down, but there's other formats that are getting used. Print is still heavy, but there are all these other formats, and then even college students are getting it different, you know, in different ways. And then let's look at the websites, because that was a pretty big one where people were using their computers. Okay, well, there's quite a few people using their computers to get that. So I think that in summary, we want to combine all of these data sets. One alone doesn't tell the story enough. And certainly when it looks like just raw data, that is very hard to look at and say, oh, okay, well, there's that. And, oh, okay, here's this. All of this together should make a story, and that story is much easier for people to understand if you organize that data and then present it in a very specific way through these visualizations. So I really do think that this section kind of organized all of that and put it together. Like, okay, we're given data, but what do we do with it?